Honors Algebra 2. Today we're going to look at section 7.5 in your textbook. It's on exponential and logarithmic equations. We've been doing expressions and how to convert between logs and exponents. We also learned in the last section how to evaluate log expressions, simplify them, and expand them. So today we're going to look at equations, and that's a big difference in this section. So we're looking to find the value of x. Since logs and exponents are inverses of each other, you're going to use a log to solve an exponential equation. So if you have an equation where the variable is in the exponent position, you're going to use a common log on both sides of the equation to solve. Vice versa, if you have a log equation, then you're going to use exponents to solve for x. And this is the same thing I just said. Remember, log and exponential equations are inverses of each other. So here is the game plan today. To solve an exponential equation, again, if it's an equation where the variable is in the exponent position, you're going to rewrite it with a common base, if you can, then take the log of both sides, and then use the properties of logs to simplify. To solve a log equation, you're going to rewrite both sides in an exponential form to remove the log, and then you're going to use properties of exponents to simplify. Example 1. Solve the following exponential equation. Again, it's good to make sure that we can recognize these. So this is an equation, exponent is in, or the x is in the exponent position. So we're going to do the inverse of exponents, which is logs. You're going to put a log on both sides of the equation. Again, we're dealing with natural or common logs right now. We're dealing with common log in base 10. We're going to do log on the other side. And then we're going to use the properties of logs. So we're going to take the power here, and in the next step we're going to put it in front of this log. So it's going to read 3x times log 27 is equal to log 81. Next step, you are going to solve for x by dividing by log 27. You're left with 3x is equal to, and then on this part you actually can use your calculator on only because it's a base 10. The LOG button on your calculator is only for base 10 problems. So find your log button. Log of 81 divided by log of 27. Okay, you'll get an answer of, if you type that in correctly, you get an answer of 1.3 repeating, which is the same thing as 4/3. Might be better to use a fraction here. And then you're going to divide by 3, because remember your goal is to solve for x. So we're dividing 4/3 by 3, which means we're doing 4/3 times the reciprocal of 3, which is 1/3. And so the answer to this should be x is 4/9. 4/9 for the value of x. Okay, and then we can show kind of a check here to make sure that this makes sense. So we got 27 to raise to the 3 times 4/9, and that's supposed to be equal to 81. So we're going to multiply 3 times 4 knots. You're going to get 12 knots. Okay, and then you're going to say 27 to the 4/3 power, which was the answer to previous question. And just to double check, like when you do type all of this in your calculator, you will end up getting 81 back, and 81 of course is equal to itself. So that's just showing me that this is the correct answer. So game plan, when you have an exponential equation, you are going to put log base 10 on both sides. You're going to use the properties of logs. In my case, I had to take the exponent and move it to the front, so it's 3x times log of 27 equals log of 81. I then had to divide through by log of 27, move it to the other side. I had to evaluate this problem that I'm highlighting right now. I ended up getting 4/3 for that answer, and then I had to divide by 3. Okay, example 2. We have 15 raised to the 3x power equals 285. We're going to use the same strategy because it's an exponential equation. We're going to use the inverse of exponents, which is a log. We're going to put a log on both sides of the problem. Okay, then you're going to use your power property for logs. You're going to take the exponent to the front. We're going to write 3x times log of 15. We'll put this in parentheses here. Equals log of 285. Okay, again, your goal is to solve for x, so you're going to divide through by the log of 15. Remember, that's just a value. That's a number value. And recall from the past, that means 10 to what power is 15? Log 15 is going to cancel on the left. You're going to end up getting 3x is equal to, and you're going to have this log expression, which I'm highlighting right now, and that part needs to go in your calculator. Remember, because it's base 10, you are allowed to use your calculator LOG button, log of 285, and then divide that by log of 15. When you get an answer, I got a 2.08729 and so on answer. When I tried to change it back to a fraction, it did not work. So I'm going to actually round this one to the nearest hundredth, and I'm going to say that's 2.09. And then I'm going to divide both sides by 3. And then you end up getting, let's see, x equals 2.09 divided by 3 is 0.70, and I have rounded that, 0.70. So that would be your value. Alright, now let's switch and go in the reverse order. This time let's solve each log equation on this screen. Example 1, we see log base 10, remember if you don't see a subscript it's a 10, of the quantity 4x minus 3 is equal to 2. To solve a log equation, you have to do the inverse of log, which is an exponent. So you're going to have to transform this equation into an exponential problem. Remember, the base is written first, the number behind the equal sign is actually the exponent, and the part in the middle of your problem, which is this binomial, is actually going to be the answer. So you read it as 10 to the second is equal to 4x minus 3. And then, easy problem, I don't see a log. I see the variable, but it's on this side, so I'm just going to go ahead and convert 10 squared and call it 100 is equal to 4x minus 3. I'm going to transpose my negative 3. So I'm going to end up getting 100 plus 3 is equal to 4x. Okay, so now I have 103 equals 4x. Solve for x, you're going to divide by 4. And you can use your calculator, but I would actually prefer a fraction answer. So when you type in 103 divided by 4, you get 25.75. It is the same fraction as 103.4. So 103 over 4, or 25.75, is the solution to that log equation. Okay, so these are pretty easy, very straightforward. Number 2, same deal. I see log base 10 of the quantity 3 minus 2x, and it's set equal to negative 1. I'm changing the log equation to an exponential, so I take base 10, raise it to the negative first power, and set it equal to the binomial 3 minus 2x. The goal is to get this x by itself. On the left side, I have a number raised to a negative exponent. That means change the position. So we're thinking like 1 over 10 to the first, or just 1/10. And then the equation becomes very easy. I'm going to move the negative 2x this direction this time. So it's going to be a positive 2x is equal to 3. And then I'm going to transpose the 1/10 across and call it negative 1/10. Alright, so the left side is going to be 2x. The right side is going to be 3 is the same thing as 30 divided by 10. 30 minus 1 is 29, so I'm just going to say 29/10. As always, you can use your calculator to verify, to check that. And you can even write it, or use your calculator to find the decimal, but again, converting it to a fraction is better. And then you're going to divide by 2. And so this is the same thing as me saying 29/10 times the reciprocal of 2, which is 1/2. And when we have fractions, easy, multiplying just straight across. 29 times 1 is 29. 10 times 2 is 20. That fraction does not reduce, and so that is the best answer. The value of x is 29/20. Okay, and that's how you solve log equations. Okay, sometimes they'll give you like multiple log expressions in the problem, and so let's take a look at number 3. We have log base 10 of the quantity x minus 3 plus log base 10 of x is equal to 1. And because I do see a big plus sign here, and first off, I see the same base of 10, I see a plus sign, I'm allowed to use the property of product property, which means I need to kind of condense this down to 1 log. So I'm going to do log base 10 of x minus 3. Remember, when you see addition, it's in the log properties, it means multiplication. So I need to multiply the pieces here. I need to multiply x minus 3 times the x. Okay. Alright, next, in order to solve for x, I need to get rid of the log, so we're going to convert log to exponential. So you're going to take your base of 10. You're going to drop that down. You're going to raise it to the first power, so 10 to the first, and set that equal to, and I'm going to turn this backwards, so x times x minus 3. And you can write it in any order you want. And so now we clearly have an equation that just says 10 equals x times x minus 3. We're going to use distributive property, get rid of these parentheses. That's going to force this equation to be x times x is x squared. X times negative 3 is negative 3x. So right now we have, based on me just doing some algebra, we have a quadratic equation. And if it's a quadratic equation with the power of 2, we know from the past to put it in standard form. The only way we're going to be able to solve is if x squared, it's ax squared plus bx plus c equals 0. So what we need to do is move this 10 this direction and force the equation to be equal to 0. So you'll drop your x squared down, then your minus 3x, 10 comes across as negative 10, and then you're going to solve that equation by factoring formula, completing the square, whatever works for you. I'm going to see if it factors first because that's usually the shortest method. X times x is x squared. Factors of 10 are 1 times 10 and 2 times 5, but we need a negative 3 in the middle, so I'm going to go with 2 and 5. Pay attention to the last sign. It is a negative, meaning these signs are opposite. I want the 3 to be negative though, so that means I want the bigger number to be negative. And then you can verify that this is the correct factorization for that trinomial, x squared minus 5x plus 2x minus 10. It does match the previous step. When you get to this step in solving quadratic equations, your next move is to take each factor and set it equal to 0. So we're going to write x plus 2 equals 0. Then we're going to do x minus 5 equals 0. And then just finish it out. So this answer is going to be x equals negative 2. And this equation is going to give me an answer of x equals 5. Alright, so these are my two solutions. Again, I got two solutions because I had a power of 2 show up in the problem. It is quadratic. You can verify that. You can check it by throwing, like, let's check 5 quickly. You can throw 5 back up here. Do like log base 10 of 5 minus 3 plus log base 10 of 5 equals 1. So in other words, log base 10 of 2 plus log base 10 of 5 is equal to 1. And check it that way. You can do it in a calculator scenario. You can actually look at it like this too. Again, right now I'm checking just the 5. So 5 minus 3 is 2. When I put 5 back into x here, it's log base 10 of 5 equals 1. I can, like I said, use a calculator here and a calculator here and add the two together, make sure it's equal to 1. You can even use a property if you want and say log base 10 of 2 times 5, which is log base 10 of 10 equals 1. And since 10 to the first is 10, I know that's going to work. So I said that quickly, but you really can check it on your calculator as well. And then you would check to see if negative 2 worked also. Okay, let's try number 4. Number 4's problem is log base 10 of 6 minus log base 10 of 3x is equal to negative 2. So I look across the board, obviously the same base. I have a big subtraction sign in the middle. I'm going to use the property, the quotient rule, to condense this one. So it's going to be log base 10 of 6 over divided by 3x. Okay, and that's equal to negative 2. Once you use the property, the quotient rule, then you're back to trying to get rid of the log, because again, your goal is to solve for x. You're going to use an exponent equation. So you're going to do 10 raised to the negative 2 power needs to be equal to 6 divided by 3x. And now you can see we got rid of the log. We're going to convert 10 to the negative 2 as negative power means change position. That's 10 to the second on the bottom, so that becomes 1 over 100. And then I just got to find the way to solve this equation to get x by itself. What I see right now is a fraction equal fraction. Ratio equal ratio, which is a proportion. You can cross multiply to solve. That's a really good way to do that one. 1 times 3x is 3x. 6 times 100 is 600, and then just divide by 3. So in this problem, x would have to be 200 for that to be a true statement. And again, you can check it. You can put 200 back up here and say log base 10 of 6 minus log base 10 of 3 times 200, which will become 600. Because it's subtraction, you can throw it back as a quotient, like 6 divided by 600, which is 1 over 100, and then 10 to the negative 2 matches that problem. Or you can use your calculator and do this part, and then type that in, and then just make sure this minus this is negative 2. Okay, so then section 7.5, exponential and logarithmic equations.